Hey everyone. Um, in your book, this section is 10.5 and is called Area and Non-Rigid Transformations, which is great. I call area of similar figures because that's really what we are doing, but that's fine. And to be honest, I printed off these notes over a month ago before we were told we couldn't go back to school, so I didn't have a printer here to change the title, so bear with me, okay? But this is section 10.5, and we are going to be finding area of similar figures. Again, this is kind of like the last lesson where we kind of have to rely on some previous knowledge in order to do something new with it. So let's take a moment and review what a similar figure is. Now this is from, I don't know, February maybe? Very long time ago. Oops, what's going on here? Okay. A while ago, right? But similar figures have the same shape but are different sizes. Now specifically, we need two things to be true of similar figures. Their corresponding angles need to be congruent, meaning that they're the exact same measure, and their corresponding sides are proportional. So remember, corresponding means matching. So if we look here, do you guys see how angle A matches angle D? They're both 36 degrees. Angle B matches angle E, and again, they have the exact same measure of 63 degrees. And angle C matches angle F, and again, they have matching degrees, 81. Now, remember, the side part is kind of, the proportional part is the not quite as easy to understand part, but remember, proportional means that they're either enlarged or shrunk to the same factor or degree. So what I always like to do is I always like to start with my small figure and pick the smallest side. So if out of my sides here I have 2, 4, and 5, my smallest side is 2, and my small side over here is 4, and if I reduce that, I get a half. Now from here, I have to get a half when I reduce my other two sides. So if I go back to my smaller triangle, my medium side is 4. My medium side on my bigger triangle is 8, and again, that reduces to a half. And as we can see, again, my big side over here is 5. My big side over on the big triangle is 10, and again, that reduces to a half. So our scale factor, what it reduces to when you pick two sides, is a half, okay? This one is half the size of this, or the bigger one's twice as big. And then just remember, this is our key. It's our roadmap that tells us what matches what. Remember, A and D, they're the same angle measure, they match. Middle, so B and E, they match. Or sides AB, our big side matches DE, which is our big side. That was like a crash course on a whole chapter we did, again, back in February. Probably talked too fast. I apologize. Again, shoot me an email. We'll Zoom, come to our class Zoom meetings, and we'll square it away if we're still confused, okay? Okay, now this is kind of the new stuff. This is our new lesson. That was review before. So we are told that these rectangles are similar. We want to figure out what our scale factor is. So again, remember your scale factors, you pick two sides that match and then reduce. Again, I always like putting the small one on top unless it says otherwise, just because that's just what works in my brain. So I see that 5K matches 5. Now, can I reduce that? Sure, our 5's would cancel out, right? So then I'm just left with K. Now it says the perimeter of figure B over the perimeter of figure A. So remember, perimeter is all the way around, so this would be 9K, this would be 5K. If I add up all my K's, let's see here, we're going to have 18 plus 10 more is 28K. Do the same thing over here, 9 and 5. So I'm going to 18 plus 10 is, again, 28. Can I reduce that? We sure can, and we get K. Now we want to find the area of figure B over the area of figure A. So easy enough. Area is just base times height, right? So 9k times 5k. 9 times 5 is 45. K times k is k squared. So the area of figure B is 45k squared. Over here, 9 times 5 is just 45. Again, can I reduce this ratio? Sure. The 45's cancel, so I get k squared. So now we're looking here because, math, remember guys, is just a big pattern. You guys notice all of our problems kind of follow a pattern. Once you learn the pattern, we throw in new numbers or a different shape, but it's always a pattern, right? So if we notice, our scale factor is the exact same as the ratio of our perimeters. So if I know one, I know the other, which is awesome. Now, what's a jump I can make from these two to this guy? So really, how do I go from k to k squared? We just square it. That's all we did, okay? So that was kind of our little investigative learning, but I really do want you though to get this down in your notes. Again, if you have it printed out, fill in the blanks, and if you're just writing your own notes by hand, make sure you get these down. So if two polygons are similar, they have a scale factor of A over B. Then their ratio of their areas is A squared over B squared. And now we're just going to do a bunch of problems going from AB to A squared to B squared, or A squared to B squared to A to B. We're just going to go back and forth a few times, okay? Okay, let's try this out. So it says, for each pair of similar figures, find the area. So again, we're told that these two rectangles are similar. Now we're going to find the missing area. So do you guys see how I'm missing the area of our small guy? So this is what we're looking for. Now again, it's just a big pattern, like I said, so we'll start here and see how it goes. So you always start with your scale factor. You give yourself a little roadmap, okay? So leave this kind of blank up here, then we'll do our work underneath it. So what's my scale factor? Again, I like to put my small one on top, so I'm going to write 5 over 8. That's my scale factor. Now from here, I want to go to the ratio, of my areas. Okay? So how do I go from, so right now I'm at A to B, and I want to get to the ratio of my area, so what do I have to do to that to get to A squared to B squared? We square it, right? So now I'm going to have 5 squared over 8 squared, which equals 25 over 64. Now from here, you're going to set up a proportion. We love proportions. And I spelled that wrong. No, I'm good. I'm good. Okay. No, I'm not. Proportion. Sorry, you guys. That's just, there we go. I knew that looked funny. Sorry, kids. It's late. I shouldn't be doing this at the time I'm doing it, but that's okay. We're all human, right? We make do. So now from here, I have my ratio of my area, so I'm going to have 25 over 64 is equal to, so remember this one represents my small rectangle. Do I know the area of my small rectangle? Heck no, so I'm going to call it X. But what's the area of my big guy? It's 32. Now from here, we just cross multiply, and we'll be able to figure out what the area of our small one is. So we're going to have 64x is equal to 25 times 32 is 800. Divide by 64, and x equals 12.5 centimeters squared. Because remember, it's area. Okay? So again, we started with the scale factor, squared it to get to the ratio of our areas, and then we wrote a proportion to find our missing area. Okay, let's try that again. Exact same process with a different shape. So again, I'm going to kind of write up here. So we start with our scale factor. My scale factor is going to be 6 to 8. I picked two sides that match. Now from here, I want to have the ratio of my areas. I'm going to abbreviate it like that. Ratio of areas. How do I get this to be the ratio of the areas? Remember, we square it. So I'm going to have 6 squared over 8 squared, which is equal to 36 over 64. Then from here, we want to write our proportion. I'm going to abbreviate, okay, just to save room. So here's what we're starting. This is what we know is 36 over 64 is equal to, now I know the area of the small one, so that's going to go on top, and I'm looking for the area of the big one. And now we just cross multiply. So from here, oops, sorry guys. We're going to have 36x, 64 times 13.5, 864, divided by 36. We find that x equals 24 feet squared, because again, it is area. Okay, how do we feel? Again, it's just the same process over and over. Write yourself your little roadmap to tell you what to do. Because now, this time, we're given the areas of our similar polygons, and we want to work backwards to find the scale factor and the value of x, so one of our side lengths, okay? So we're going to work backwards, like I said, kind of. So this time, we can start with the ratio of our areas. Again, I'm going to put my small one on top, so I'm going to have 50 over 72. I'm going to reduce, and you should always reduce because you'll find that most of the time we're given perfect squares if you reduce it. Because if we notice, I can reduce both of these by 2, so then I get 25 over 36. Which are going to be a lot nicer to work with. Now from here, I want to find my scale factor. Now how do I go backwards? So if I'm at a squared to b squared, and I want to get to this a over b, how do I undo something squared? We take the square root. So if I take the square root of 25, I'm going to get 5. If I take the square root of 36, I get 6. So there's my scale factor. And then from here, we can write our proportion. So I'm going to have 5 over 6 is equal to, now 5 corresponds to our small one, so that's my x over 6. Now we cross multiply. 5 times 6 is 30. 6 times x is 6x. Divide by 6 and x equals 5. So to answer the question, our scale factor is 5 to 6. The value of x is 5. Okay? Let's try another one like that. I would love it if you would pause the video and try this one on your own. It's the exact same format as the last one we just did, just different numbers. But I know it's kind of scary sometimes, so. But if you want to try to challenge yourself, pause the video, and then I'm going to do it right now. Okay, so again, I know my areas, and I need to work backwards to find the value of x. So again, since I know my areas of my two polygons, we start with the ratio of our areas. I always like to put the small one on top, so I'm going to have 64 over 400. I'm going to reduce. You don't have to reduce on this one, but just to kind of keep us in the same process, you can reduce these. 16 goes into both of them. So if I divide by 16, I get 4. 400 divided by 16 is 25. Now to get my scale factor, remember we take the square root. Square root of 4 is 2. Square root of 25 is 5. Now from here we write our proportion. So I'm going to have 2 over 5 is equal to, now x goes with the small one, so I'm going to put x on top over 40. And now we cross multiply. So I'm going to have 5x equals 80. Divide by 5, and we get 16. So now to answer the question, our scale factor is 2/5, and our value of x is 16 millimeters. Okay, one more left in notes for today. Little application problem. It says the area of one side of a skyscraper is 90,000 square feet. The area of the corresponding side of a scale model is 20 square inches. If the skyscraper is 720 feet tall, about how tall is the model? Oops, that was all crooked for you. Sorry, kids. If it helps you to draw a little picture, maybe do that quick. So we can just draw here. Here's our skyscraper. Has an area of 90 feet squared and is 720 feet tall. Here's our model. What does it say? It has, we want to find, so it has an area of 200 square inches. How tall is the model? So that's what we're looking for. Okay, so right now you need to decide, do I get to start with our scale factor or do I get to start with the ratio of our areas? Which one do we know? We know the areas of both of our figures, right? So we're going to start with the ratio of our areas. Again, I'm going to put my small one on top. So 200 over 90,000. And yes, they have different units, but when you write a proportion, your units, your feet and inches will cancel out, so there's nothing to worry about here. So kind of forget about your units. If I reduce this, I get 1 over 450 because 200 goes into both of those. Now from here, find your scale factor. So again, I need to take the square root of both of these. Square root of 1 is 1. Square root of 450 is 21.2 when we round. And now we can write our proportion. So I have 1 over 21.2 is equal to, x corresponds with the top, 720 down here. Cross multiply, so I have 720 equals 21.2x. 720 divided by 21.2 is x equals about 34. So it's approximately 4 inches. Okay, well, thanks for tuning in. You guys are super. Be united. Live the tradition. Onward Central. I miss you. Have a super day. And I will hopefully see you in one of our Zooms. See you later.